Hello everyone. I think we can start. Okay. Oh no, answers. Nobody saw that. Oh, shit. Okay. Here you go, the slides. Way easier lesson than the previous one, this one is, so should be easy and fun. Let's go. So the purpose of this lesson is to talk about arrays, different kinds of arrays, and about one more data structure that is very commonly used. So we'll talk about array of arrays, multidimensional arrays, jagged arrays, arrays with more than 2 dimensions, and a dictionary. So let's start with 2D arrays. 2D array is basically an array of arrays. So the same rules apply when you create an array. You have to specify its length. And since array of arrays has different arrays at each element, when you access that element, it will be null by default because elements of the new array are always null, the default values basically. So if I access, if I create a table with 2 rows, row 0 will be null, and row 0 will be an array as well because it's a 2D array. And you can see it's a 2D array from those brackets. This bracket means it's one array, and this bracket means it's a second array. So it's an array. So it's an array of arrays. And here I say I create an array with 2 elements of arrays. And here I say that the first element will have 2 elements in its array, and the second one will have 4 elements in its array. So the whole point of a 2D array is that when you have individual rows, they can be mismatching. They can be 2, 4, 6, 9, or different size, but not consistently. And when you index such array, it's also quite simple. You can either, so if I call 0, if I say table 0, I return a row. If I say 0 again, indexing like this, I return the element at that row. So in the comments you can see I get the first row with the first element, and here I get the first row with the second element. Quite simple. And same rules apply. Array of arrays is just an array of arrays. There is nothing special about it. If I want to get length, like how many rows are in the array, I can use length. Or if I want to get how many rows are in the first row, I can use length of 0 of first row. Next. And in C# probably in other languages too, you're not limited to how big your array can be. You can have n-dimensional arrays where n is any integer. So if you really need to, you can create an array with 1,000 of dimensions, but it would probably be horrible performance and nobody does that. And with every extra dimension of array, the complexity increases. You don't really want to complex yourself without a good reason. But the same rules apply no matter what dimension it is. Yes, cat girl, we'll talk about it soon. So the same rules apply. When you create nth dimensional array, you initialize the first dimension for that array, because you must provide the size of array. And this is actually an array of a single dimension. It might be deceiving. It's a single dimension and therefore length will return length of this array, but it behaves quite differently in different contexts. You cannot make an array with unspecified size in C#. You can create a list with unspecified size though. Therefore, a list is more popular in C# than array because it can shrink and expand in size. But you must provide size. Oh, well, because this array doesn't know what dimensions it has, each individual dimension. So if I access this array and get its, let's say, first element, I get this array. And this array is null. So a null, like all those elements in this array that I just created are null. So that's why it works, because it doesn't exist in the first place. If you want, you can create an array in that slot, and then you would specify size. So if I took first element in a 3D array, I would get a 2D array. And if I wanted, I could create a 2D array like this. And then if I accessed a 1D array, like any element from that 2D array, I could then initialize 1D array from it like this. So it's a lot of backtracking, and therefore it's too complex to be practically used. So jagged arrays. Now let's move on to something more interesting and probably more practical. In practical sense, I've seen more jagged arrays than n-dimensional arrays. Jagged arrays are very similar to n-dimensional arrays, except that they are kind of organized. They are strictly with matching dimension sizes. So for example, I cannot have some rows with dimension size of 3 and other rows with dimension size of 5. So therefore, it's the other way around. Okay. Anyways, yeah, please check. Anyways, jagged array has, okay, so this is n-dimensional array. Okay. All right. Doesn't matter much. It's just a term. Okay, so then I'll fix fast. jagged array dimensions going beyond 2D, 2D arrays, plus arrays, jagged arrays. Okay, great. Let's go back. Yes, so n-dimensional arrays, then when you create them, you need to specify all the dimensions because all rows and all of the dimensions have the same lengths, the same sizes. And the syntax type for its definition is this. So here we just created a table, basically a 2D array with 2 elements in each dimension with 2 dimensions. First dimension length 2, second dimension length 2. And here we can get first element of first dimension, and here we can get second element of first dimension. And I think the interesting bit is when you start working with lengths of dimensions, because that is a bit confusing. Because length of dimension in a 2D array doesn't work the same as in multi-dimensional array, because if you try to get length of a certain dimension, you just cannot access it from another array because there is just one array essentially. It's not array of arrays. So you need some different way of accessing length of a dimension. So what does this give you? How do we work with dimensions? So imagine we have 1, 2, 3, 4-dimensional array, because 4-dimension length specified here. So length in a context of this jagged array would actually give us the total amount, the total count of all the arrays in the table. So if I do table.length, I get actually all elements in the table. The total count of them. So 2 times 3 times 5 times 6 is in total 180. And if I get, so how do I actually get dimensions length? I need to use getLength function. So if I say getLength 0, it gives me the first dimension. If I do getLength 1, it gives me second dimension, and so on. So it's a way of getting dimension lengths with jagged arrays. And now just a notable mention, dictionary. So what is dictionary? Dictionary is a key value pair. So it means if you pass a key, you get a value based on that key. And it's used basically as a translation mechanism. So for example, you could pass in a word in one language and get a word in another language back. Or you could pass a key to a person, like person's ID, and get the person itself. So it's essentially like a list, but for key value pairs like JJ Cube mentioned. So it's also generic like list, but but instead of accepting a single generic argument, it accepts 2. So it accepts 2 generic arguments, which might be different. It might differ than just string and string. It might be string and int or anything else really. And yeah, so in this example, you see how you could potentially do mappings between different languages. So here I have a literal dictionary which translates Lithuanian words to English words. So I passed in labas, and so labas is my key and hi is my value. Iki is my key and bi is my value. So if I want to get an actual translation, I could just pass the key, the word that is a translation, and get back the translation. So native language word passed to get a translation. Yes, you can use any type as key. Even object itself can be a key. Like you can use a reference as a key. So object initialization in dictionary. One really neat thing about C# is that it supports object initialization, which means that you can actually initialize all the mappings while you're creating a dictionary. So here you basically see I created something similar that we did with a switch statement a few lessons ago, which basically maps numbers into words that they represent. So 0 int is 0 word, 1 int is 1 word, and 2 int is 2 word. So why do we need a dictionary over an array or list? Well, first, or actually for me personally, it's the last reason, but it is faster. In most cases, dictionary is faster for lookups. And this is a performance comparison at the bottom that you can see. And in here, why do we need dictionaries altogether? It's great for mappings. And it's also great for solving certain problems. For example, if you had to find counts of letters at word, it would be crazy to not use dictionary, and I wouldn't even know how to do it without using dictionary. So it's very suitable for certain problems. And yeah, lookup itself is O1 because it's a hash table and that's how they work. Though dictionary doesn't have to be a hash table, it just happens to be implemented that way in C#. Do you have any questions? And if you don't, please write one thing that you learned in this lesson and that you remembered very well, that you understood very well, or at least you think so, and one thing that you would like to understand better or you're curious about. So one thing that you understood very well and one thing that you would like to understand better. In the meanwhile, I'll give you a few minutes for that. Okay. Let's see. So also there was a remark. What would happen if you call from dictionary a value that doesn't exist? You would get an exception. I don't remember what exception, but it would throw an exception. So it doesn't work that way. So Chubby Kinder said that you can call out dictionary's value straight passing in key instead of dictionary key.value. Yeah, that's true. Because you don't get key value pair back, you just get a value back. You get key values when you're for eaching a dictionary. So Hellhunter Max asked, is it good to use it instead of a list sometimes? I do believe so. If you really truly think that you're going to do lots of lookups and you need that speed, you won't have that many additions and instead a lot of lookups, then probably it is better. I will play around in live coding after the quiz, after answering your questions to check the performance myself because I'm curious, and I'll publish the results. All right, so roll off. Okay. Going back to what he said about key value pair, you can use those to do a for each loop for a dictionary. Yes. A while ago, we made it so that we can create our own way to index stuff. Could that be done on multi-dimensional array? Say we are making a chess game and want to check what's on board. Yes, you can do that. And another thing is, how does a custom type as a key for a dictionary work exactly? Does it need to be the same object? Yes, it does need to be the same object. Chessboard is a multi-dimensional array. That's a good example. Yes. Or actually, no, it's, yeah, it is multi-dimensional array. It's not jagged array because it matches. It has stable lengths for dimensions. Yes, that's how you would declare that, like passing row and column for placement coordinates. It works in both Java and C#, JOStriker, jagged arrays work in both. All right, I think all questions are answered. So let's move on to live coding part. The bit I'm curious about is benchmarking stuff, is comparing dictionary to list. How much faster is it really? So let me create a new project. How would you do that? I think it's console application. So let's place it in our source. Let's call it dictionary benchmarks. And let's play around with it. All right. Yes. So let's add a nugget package. You don't need to understand what I'm doing right now, because I'm basically just adding a package which allows me to make benchmarks. I won't unit test because it's inaccurate. There's literally a library for making very accurate benchmarks. Okay. Okay. Let me quickly Google up how to run it. C# benchmark.net. Boring, 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 boring. This is the one I wanted. Okay. And we need to decorate this class with stuff that we can benchmark. So bear with me. Dictionary versus list. Okay. Now, come on. Why is it not picking any of those? Dictionary versus list. Great. I will actually remove the other package then. The core one. Not sure why is it not functioning. Like, great. We don't need this. So let's benchmark. Right. So dictionary lookup with 10,000 elements, with actually a varying amount of elements. Lookup with 1,000, 10,000. Yeah, this is good. Great. Private, static, void, lookup. And we say how many elements we have for the dictionary. We say we have count. So we create a new dictionary. Dictionary with, let's say, strings. Actually, let's say ints will be easier. And let's do a silly dictionary like this one. So for this count, let's create a dictionary with and populate it with those elements where key and value will remain the same. Not count, but I and I. And that's our dictionary. I'll extract this to a method. Create build dictionary. So we have a dictionary which I will build at the start. Dictionary for int for 10 right, it needs to return a dictionary. int. Static method because we want to call this, we don't need to really initialize the class to call it, that's why. It's like a helper method, a stateless helper method, therefore static. It can be non-static as well and nothing would change, but static makes it slightly faster. Return dictionary. So we built a dictionary of this size. Let's build a bunch of dictionaries. So of 100, of 1,000, of 10,000, of 100,000. Okay, and a few more. Great. And let's do a lookup to different dictionaries. So I'll pass in a dictionary and I'll try to find its element in that dictionary. Key. So we do a lookup and we return from that dictionary that key. And we make sure it exists, and I'll try to make it so that it's always the last element. Lookup. So it is int. Okay, so in my benchmark, let's start with 10. So we do lookup for our dictionary with 10, and we search for the 9th element. And let's make a bunch of tests. 100, 1,000, 10,000, 100,000, million. 1,000, 10,000. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. And one more. 0 and 0. Great. And just let's add 99, 999, 9999. 99, 999, 999. Okay, good. Dictionary count -1. Not sure what you're asking. So here we have a bunch of methods for dictionary lookup. Missing 1, 9. What? 5, 5, 4, 5, yeah, 6, yeah, thanks. Oh, yes, I could do that, that's true, but I wrote that already. Okay, so we have dictionary lookup methods. Now let's see how fast, how does it compare to an array? If we were to look up for an array element in a for each. So we have dictionary lookup and we need array lookup. Let's do some fancy replacements. Great. And instead of underscore dictionary, it'll all be underscore array. Great. And let's create a bunch of arrays, shall we? Whoa. Private, read-only, int array, array 10. Yeah, array 10, 10, 100, 1000, that, no more. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We don't need this one. Okay, let's create a bunch of our arrays. So instead of taking a dictionary, we'll take in an array. And instead of a build dictionary, this will be build array. Count will remain. We create an array with that count. It's an array. And we just populate nth element with that kind of value, and we return an array. And here we have also an array of int. Build done, lookup done. Yeah, it works. We don't need to change anything. Overload will handle it. So we have lookups benchmark. Now we can run it. It's not O1, it's ON for arrays. Because it scales based on the amount of elements. It doesn't work that way for a dictionary. It should start up a benchmark. Which defines benchmarks is non-optimized. Yes, I need to run this as a release mode. I'm excited to see the results, to be honest. It's not O1. I mean, so think, how many iterations will it be? Oh, you mean that one. That one is O1 probably. Yes, that one is O1. If I did a more silly loop, it wouldn't be that. Probably, yes. Yes, sorry. We'll see. Actually, I don't know. This thing that we have here, it definitely needs to amount to something, because under the hood it's still an array, and there is a significant difference for dictionary. So maybe I'm wrong for indexing. Maybe I'm not. I'm not a low-level guy, so I cannot really say myself. Wasn't in a situation where it would matter a lot. It takes a while, so let's just let it run. In the meanwhile, let's compare how long does it take for So Aurora asked, wasn't the point of the benchmark to point out that if you did need to use an array, it would need to iterate over all of the elements? That's what makes it ON? No, I don't think so. Though I'm not sure. It's a different way of working when you have an array and a hash table. It works differently. It's been probably a decade since I last learned about it. Okay, there's a bunch of benchmarks, so let's give it a spin, let it work. I'm also curious about initialization. How fast does a dictionary build happen, and how fast does an array build happen? Because that's also another part, an important part. So public void dictionary build benchmark. So for 10, in any case, it has to differ. It cannot be the same. Dictionary is not hash, like array is not a hash table, and hash table is faster. That's all. Dictionary build 10. So build dictionary with 10. Let's add a bunch. 1, 2, 3, 4, 5, 6, 7. 1, 0, 2 zeros, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, 6, 7. 1, 2, 3, 4, 5, 6. I think that's fine. Oops. Oh. 1, 0 too many, I think. Yeah. I think that's fine. And public void array build for 10. Okay. One, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Good enough. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. I forgot benchmark. Benchmark, 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 benchmark. How's it going? Okay, we are done. Something went wrong. What went wrong? Not any results. So dictionary lookup took us this long, and it was the same amount of time every time basically. But for array, nothing happened, and I don't know why. but let's have a screenshot of this. Weird. I didn't use array lookup. I did use array lookup. Oh, I didn't assign them, so they just gave an error. Sorry, guys. Okay. Yeah. Okay. Makes sense. So they just throw an exception. That's why it failed. One, two, three, four. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, now let's comment this one out for now. And let's comment this one out for now. Let's run the bench. Actually, we don't need to run all benchmarks. Let's just run the one with the first and the last. Let's just run those, because that would make a point clear. If they all return number in the same time, that means that they are based on the same. Let's see. Here are the results of dictionary again. Literally the same time that it took to find the value. Let's read what internet says about hashtable versus array. Hashtables and arrays. Explaining arrays, uninteresting. Examining hash tables. Yeah, so you see, array still does a lookup. So it needs to go through all the elements until it finds the last one. So in this case, I really expect a difference. And a hash table just points right away to the answer. We'll see. I think it does. We'll see. The method duration. Zero measurement. The method duration is indistinguishable from empty method duration. Yeah. But why do we have warnings? Why do we have warnings? The method duration is indistinguishable from the empty method. From the empty method duration. I don't understand what it means. Why is it... Okay, this taking that one, this taking that one, it does take those. Okay, so comparison of search and hash table. Why is it memory search hash table search array? You see it's different. What does it mean search then? It contains something. But what's the difference? Like, if I were to do a for loop for each, that would still mean I go through everything. So, and search to me just means I access it directly. But I don't like that I see warning here. I don't understand warning. Zero measurement. It's not, but search isn't either. Search isn't doing a loop either. How do I fix this? How do I fix this? How do I fix this? Give me 10-minute max. So you're saying if you want to see if an array contains something, you would need to go through every element. And if you want to see if an array oh. So what about a dictionary then? If it contains something? Well, it has those methods for contains. Oh, okay, so they did it like this. Okay. And how did they act with this? My data. Okay, so they switched keys and values. And here... No, they didn't. Never mind. Right, so they had objects there. Okay, well, it's obvious that if you loop through something, which is an object, and you do a search like that, you will take longer than just accessing it directly. But it still doesn't make sense. Why do I get a warning like that? Is it because I did a benchmark that basically finishes instantly? Lookup array of 10 elements and find a key. So it works like this, and this one works like... It's a silly example though here. You compare different operations altogether. Because in this one you access directly, and in that one you for loop through it. So of course it's slower. Okay. Come on, come on, come on, come on, come on. The method duration is indistinguishable from empty method duration. So it's probably that fast that it didn't take any time. That would be my guess. Okay. So for this one, we have 5 nanoseconds, and for this one, it's basically instantaneous. Yeah. So I did have a misconception how it worked. Okay. Again, I'm not a performance guy, as it was never a concern of mine. So a conclusion from this is that dictionaries are faster when you need to get a value based on a key. But when you are still doing indexing, which is if you're still using a list or an array and you just pass in an integer, it still beats dictionary. Because as we saw there, it doesn't need to do the hashing and getting value by hash inside an array. Because list and array are essentially just getting the value directly from somewhere. And that is linear. Yes, as mentioned there. Okay, educational for me as well. Anyways, this one will cost some time for sure. So it's quite interesting to see that one. Let's comment this. And let's comment this. Basically, we're benchmarking the price of building a dictionary over building an array. This is fine, this is fine, this is fine, this is fine. Okay. And I will run this and we'll start Kahoot in the meanwhile, because no point of waiting. Done. I will have a second look at it because I edited the questions about mixing jagged array and 2D array, so I'll just quickly look at it. Is it true? Okay. 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 Crap, one is wrong. Okay. Question mark. Okay. 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 Awesome, wasn't running. Nice. Okay. Kahoot time. Okay. Join, join, join. How's the benchmark? Start. I did. Okay, so is it true that multidimensional array does not support 4 or more dimensions? Yes, next. How to create an array of arrays of type int? So you need to provide an initial length of array when creating it. So the first answer is wrong for that reason. Oh. Hellhunter, Resho, everyone except Aurora. No, it's not. Because first brackets indicate the length of array, not second. If a matrix is a jagged array of int with 2 dimensions, how do you get the first element at first row? So jagged, yes. It's normal, and it's even silly. Like, if someone were to evaluate this, it would be silly to punish for something like that because it's just a term, and I myself have mixed that, so it's fine to not answer this really. But the answer is the square, because jagged array is an array with varying an array of arrays, basically. Is it true that in a jagged array, .length will return the total count of all elements? So it's an array of arrays. Will that length return total count of all elements? So Aurora said, because an array of type is just t, so if an array of array, it would be t, where t is t, so t second t bracket. Yes, but it was not t, but it was int, so it was wrong for that reason. How do you create a 3D array? Too little time for this one. Crap. Way too little time. Hurry up, guys. Okay, good job. How to create a 2D array with first dimension length equal 2 and second dimension length equal 1. 2D array. Yes, okay. Is it true that getLength1 is the get count of array elements for a jagged array? Well, it works only on a 2D or more D array. GetLength doesn't work for jagged array because one would throw an exception because Jagged array is an array of arrays, and an array of arrays has a dimension of 1. So if you get length of something that has only one dimension, you'll get an error. If we want to get third dimension length in 3D array, which would be the correct way of doing it? Yeah, the answer is this. The answer is not this because third dimensions start from 0, so third is actually of index 2. And it's not this one because it would be for a jagged array if given it has elements that are not null. Var array is new int 323. What is the easiest way to count the total of elements in array? Total count. And it's triangle because that's how length works for multidimensional array. It works, that's how length works in general, actually. Multidimensional or single dimension or jagged array, it returns how many elements that array has in total. What's high in Lithuanian? So, yes. There was a hint because there was a dictionary which literally has a translation. One to another. There isn't an inbuilt function. There is. Actually, there is a function, but you cannot know that one yet. It will come with LinQ lesson. Array by itself doesn't have it, but LinQ has it. Mihail third, Resho second, and Aurora first. Congrats. Let's see the benchmark. Come on. Okay, Let's see the results of benchmark. So building dictionary takes literally 100 times more time. Actually, what? This is really interesting, I would say. And I cannot explain it. I suck at performance, as you already saw it. Well, it's weird. It's really weird to me to see this. Oh, okay. I forgot to add. Okay, makes sense. Let's take a screenshot for dictionary. Let's run array again. Just the array. 100, 1000, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. All right. So for dictionary, it's pretty expected. Like it is n, the complexity. It's not square, it's stable n. So literally in proportion to the amount of elements, linear proportion. From 10,000 to from 1,000 to 10,000. Yes, thanks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. All right, let's give it a go. Actually, let's run a few less. We don't need to run that many. Those will be enough. Not much time. Let's not waste your time. Let's not waste my time. Okay. Nope, no more games. That's it for Kahoot. Only the benchmark and homework. In the meanwhile, while we wait, homework. Not all got pasted. 2 and 3. Ignore the first message. The second and third messages are the homework. I'll post on Discord as well. Okay. Let's compare with dictionary. Where's dictionary? So 10, 100, and 1,000 up to this point. So initialization, addition of elements, was almost 30 times faster than dictionary. So that's nice. And the others, it wasn't that much proportional as well, as it was not taking longer than almost 10 times, but not quite. When you increase 10 times the size of collection, like it didn't grow 10 times in amount of time it needs to do. The initialization. And for dictionary, it seemed to be the case. But for array, it's slightly faster than 10 times. But yeah, the initial initialization is 30 times faster than dictionary. Okay, I don't have any more remarks. Any more to say? Do you have any more questions? Okay. Thank you for your attention, and see you in the next lesson, where we will be talking about delegates, or in other words, functions as variables. Good night and see you.